Any questions?
Yeah, actually. So if you open like the I was looking at, again at the heist. If you, I think there's one part where like I don't understand it. Um, I don't know. Maybe you can open it and like go through that part of the code where it's here. Let me make sure to let me make sure I'm saying the right part. I need to open my idea. Um, it's there's a part in the heist where it does something about the like the format, and I don't understand that part. Like where it's like you can like change all the formatting and like it's like a table. I think it's called.
Are you
Oh my,
are you
I don't
sharing?
have. No, I can't because I don't have the project anymore. I need to open it.
Okay, probably. Well, I can share.
Yeah. Oh, yeah. Here, I'm just. I'll find it. Let me find it on the GitHub. It's it's the one where it's the the color palette, where like it shows like the art, like it generates the colors in an order.
Okay, so let me take a look. Um, SD project. You mean it's sample project, right?
They put it under like examples or something. Yeah, it's one of the sample projects. Yeah, it says color palette right there.
This one. So let's see. So I'm trying to compile and see what happens. Um, Canvas theme default. By the way, this is also my first time looking at this code. Color space. So look at somewhere like in the code.
Yeah, it was the part where it says here, it says like yeah the color. Wait, go up a little bit. It's the part right above this one. This imp color space for palette, and then the two things, and then loud. And I didn't get what that meant.
You mean here?
Yeah, that part. That's what I meant.
Okay, so I get this running. Uh, since you can change the color. Oh, let's see. So let's see what is palette. So palette is actually another library. And from the name, here's a lab. So it's implementing something defined here, which says is a device independent color space which include all uh, perceived value, perceived variable colors. It's sometimes used to convert between other color space. Um, and sometimes in color manipulation. So do you have some idea about like color space?
Not really. I don't know what that is.
Right. So you see the color can be represented as different numbers, right? RGB, red, green, blue. So if you change the red, somehow frozen. So if you change this is like 3 parameters. If you just change the red, it's going to just increase the first red number. If you just look at the first RGB value, right? And this is one way to represent a color, but you also have other ways to represent a color, like HSL or SSV. To some extent, those are like hue and saturation. Forgot the last one. So they actually represent the same color, but just by using different space, different dimensions. So human's eye can only see a small part of the light spectrum, right? So I think Wikipedia has something, and those like professional monitors can display, like the okay, so this triangle says something. So basically this is like if you buy a monitor, the more expensive your monitor is, so you can have more colors, right? Like you if you have how many colors is basically encoded by how many numbers you want to represent your color. So if you see this is a color space, this is pretty much like human eye can perceive a color space. So there are like certain areas. So those are roughly projected to the areas. So human can only see from the wavelength perspective, right? We cannot see we cannot see microwave, we cannot see like ultralight, but some animals may see, right? Like I don't know, like maybe like dogs or some other animals. Like some shrimps in the ocean can see like a very wide spectrum. So human eye can see a certain space, like a part of the light spectrum. So for monitors, right, we're talking about when do programming, we're talking about how do you represent those colors. Then there are like red, green, blue. We use those numbers. 0 can represent certain, like maybe this triangle or some area of this color space. If you go to like professional monitors, they can show a larger space, right? So their encoding is different. I think like the human eye can see certain portion of it. So I believe this program is trying to, right? This is a UI trying to give you the palette means that you're trying to mix, like find the color, right? This is your if you're drawing a picture, palette is like you are adjusting your colors. You find the perfect color you want. So this is basically you tune those parameters. You can find a color. So we'll see what this does. So this one says it's a lab, right? This lab is trying to is a struct. It's it defines certain functions. L, A, B, like L is lightless, A is like a green, red and green and yellow, something like that. White point associated with color illumination observer. So there's some very specific terminology. So I don't know exactly like how those conversion does, but if you look at those different like standard, right, like CMYK is using a different value to represent RGB, red, green, blue. And also like for this one, this is like a hue, saturation, maybe like illumination, light. So it's like if you enlarge this value, it's become more bright. And if you adjust the saturation, the color becomes more dense. So this one, the hue is another dimension. So your question, what's your question exactly? Like for the data structure here, or just for the
Yeah, I didn't understand where they were getting the lab from.
Where did I get that from?
Yeah.
So for the syntax wise, this is an implemented trait from like Rust syntax wise, right? This lab if you on Mac click the command button, I can trace it to this library. And the definition of lab is here, right? So this is the definition of the lab in this file, in this palette library. And so for that particular, there it is. Close some. So color space is a trait, right? It has it's like an interface. So it says I need to implement this new function, components function, and toString function, in order to say I implement this this trait. In Java, it's like a probably interface, right? And this syntax is saying I'm implementing this for, so you see the concrete implementation here, right? When you see this function is implemented, right? You see the curly braces, they actually give you some values, but if you only see the color space, they don't have implementation, they only have declaration, they only have the signature, what's input, what's output. There is no implementation, right? There is no brackets, so we only see, this is like a blueprint, right? I need those three functions, but I don't give you concrete implementations of it. And here it does implement that by actually writing out the what's in the body of the function, and it implements this for this struct. So this lab is a struct. So this lab is defined here. This lab doesn't have that three functions, right? So this lab itself, before this implementation, this lab structure defined here don't have those three behaviors, right? Those three functions. You cannot call like a new function on an instance of a lab. But after we implement this, anything we did, like we create a new instance of the lab, we can call those three functions. I'm not sure that that's the answer. Like for Rust language behavior. For the technical side, right? This lab has a lot of things to do. Seems like about those some of those maybe mathematics about like how to change those colors. think those are like x, y, z, epsilon, cosine, right? You see those formulas? So it's doing something about like conversion formulas, right? I can guess it's kind of calculating, calculating the points, kind of do a coordinate transformation, right? From one standard to another. That's my guess. And syntax-wise, I think that's my answer. You can also see they also have not lab, right? Also HSV. So I actually think lab is one standard, right? It's one kind of way of represent color. This is HWB. So palette is probably like a gallery, a collection of those standard. How do you represent colors by different coordinate systems? I think lab is probably using LAB values. If you look at that, right, we see LAB, which make a lot of sense. You see, L is lightless, A is something about red and green color, B is about yellow and blue color, right? So this is a way of represent the color, I believe. Like if you use some value LAB, actually exactly here, right? See LAB here. They are those three parameters, right? This first one is lightness, right? Yeah, makes sense. You see, if I draw, make it to the far right, it's become more light. This is dark, right? It's lab. So I think here it is, right? Lab is like you're using LAB, those three values, to represent a color. And you can also see, right? This is this does dynamic adjustment to all the other values, right? I'm changing the lab value. I'm changing the A value, right? I'm changing the A value for. You see the L value and B value don't change, right? If I change the L value, to some extent, you see this is trickiness, right? This is like they're not all linear, which is interesting. See RGB, they don't change, right? You see like if I'm changing RGB, red, G, B, the other two doesn't change, right? The other two do not change. But for this one, it's interesting. The L, like if I am moving, at some point the other two also start to change. So there are some math involved around. You see those numbers, right? If you look at this chart, it makes a lot of sense. Some of them are triangles, some of them are like ordered shape, right? So the math behind that is we are converting those values from one coordinate to another. Also, there may be some particular math about even within the same space. It's not all. If you look at the shape, right? Some of the shape is not like a triangle. Some of the shape are actually odd shape, right? So it makes a lot of sense, right? You when we drag the value to a certain point, the mass is not linear anymore. It's going to be a different mass. So I think that's I should give you some idea. At least I'm certain this LAB is corresponding to a color, right? If you assign three values, is going to be a color. And here the behavior is we get a new, right? The new it create a new instance. We assign L value, A value, B value, which is the behavior. We create this color, and the components. Well, it seems straightforward, right? We get the L, A, and B value, seems at a rate, and then this two string value is a representation, right? Get a string. So I think this is a very standard kind of wrapper around the library. Right? This library already provide create a new color, also provide the value. Right? The component just get a value. It's like a wrapper function. ToString is also like this, just print and you get a string value. So all this color space is a wrapper around. I would say is a three function to enhance the behavior of this lab structure, which is lab structure actually implement all the details, right? Like clone and I think those computations, right? When we use stuff, it actually does something. And I think the more tricky part, right? The actual math about it is defined here, right? How do you from one color to another? How do you get those things? Those are math pattern. Any more questions? I think seems pretty straightforward. Unless you want to understand the math, then you can look at the formulas, but probably pick up like some books or something particular about the conversions. I think those are pretty technical about like which standard, use which number to represent the color. Is that a satisfactory answer, or you're looking something?
Yeah, I understand. So I didn't know. Yeah, I couldn't find where the lab was defined. But I didn't know what it was. Yeah, but now I get it. Because I always thought the lab was like I thought it was like a different, like a module or something.
Yeah. So you can in this IDE, right? You have you can click. You can hover using the command key or Windows maybe Windows key. I don't know, like Alt key. It help you navigate. Cool. So also I learned something new, which is pretty cool. Okay, I am going to. I'm actually in the debug session for the Android. For the Android piece, so I probably can show something about the Android development, the Android code. We haven't shown that before, right? At least in detail.
Yeah, we didn't do the Android code yet.
Yeah, I can show something. So the developers actually push a lot of code in, and it kind of breaks Android and iOS code. So at a high level, I think that's probably look at what's Android UI. This is not an Android UI. This is the iOS UI. But you look at the UI. It's pretty much the same like the desktop UI. It's just in a different layout, right? And this node section is very much the same. The Android UI is also very similar. Like this is the Android UI. I cannot show the actual font, but so this is the Android UI. You see those every record is here. You have this tag. We have more or less the same elements. The iOS UI is kind of very similar. You have a search function, things like that. They are very similar to this desktop UI, the selection one. And so the development for Android is like you're going to use this Android Studio for the normal, right? The standard practice one. So when you create a project, you kind of having those Android project structure. This is already like flushed out. Right? We already have this project here. So the main component are those I would say Java code or JVM code. We have a bunch of code here, which is the UI piece, which is the interaction piece for the Android interaction. So this main activity is like the entry point for the app. Right? Main activity means the actual app, the main UI. So there are certain other concepts, right? You can have a different widget, which is also in the app. Right? You have like notification and other things. So an app is, but the main UI, right? You actually click the UI icon, you click the app icon, and what it shows is the main activity. So activity is like a concept in Android. Like you trigger something, the application main, the main app UI is like a main activity, is triggered by like main activity. And there are also something called intent. Like when on an Android app, right, you click on something, sometimes directly launching an app from a web URL or from some other app, right? You can like you want to select the photo. You have like those reusable UI, right, to select the photo, select the file, take a picture. So those are activities, which is like a trigger to trigger some event, and the event is called roughly called intent. I mean, intent to take a picture, and that intent is captured by something, right? Maybe by the camera app or by something of the of a program which can deal with the intent and trigger that app's UI and completes that thing, right? Take a picture, and after take a picture and done, the picture is the content of picture is shared to the original app, something like that. So in our application, right, in this particular bookmark application, right, we're doing things the similar ways, right? So in Android device, when you're using Chrome, you share the URL. I cannot demo this, but you can imagine it's kind of similar. You on a mobile browser, we have that share button. It's not exactly like the desktop, like an extension, but you can share the URL, share the current page. When you share the current page, it actually creates an intent, and that intent is captured by our application, and when you save it, it saves a record here. So it's very similar to the desktop applications like extension, but it's just in a mobile way, right? In a mobile way. So here let's look at the code. So there are this actually, the intent is something like a share activity, right? So when we actually in the mobile Chrome browser, we click the share, it actually triggers this activity. So this activity kind of we can kind of guess from this. We get some information about this page, the URL, the title, and some other things, and we kind of handle that. Information. We kind of or something like a queue. We kind of handle this activity, right? We start this activity, we start this event, and here is the main activity. Something like that. There also something about permission, right? You can do this to cross talk, to talk to another application. You need some permissions. The idea is this share activity deal with the actual browser share the link, and this main activity is actually the main UI, which kind of if you found this name, you can see it handles the query, which is a search bar, right? Which is search bar, and we handle like when we get the result from the database, we show something, right? So it's very similar to the desktop application. Every query we get a result, and all the rendering of those results of this record are actually some data structure we get back from from the same database, right? SQLite database. So we capture this database. There are certain other ways about like the UI. We click the previous button, next button, you do the pagination. So also here we do the search. There are a bunch of things about permissions. So the main activity is very simple. It's directly corresponding to the UI elements. Like we have query, we have search, we have a bunch of other things. But basically that's it. So Android, we have this particular UI layout thing here. So you see they actually have those more or less what you see is what you get, but not perfect type of way of doing this UI component, right? So it's actually XML files. This is like a UI for those XML files, but actually they are just text files. So those files are when we directly open like this, they're shown as a UI, but they are actually text files. It's interesting. Code, okay, here. Okay. So you see it's very much like a web page, right? Web page design, HTML, the same thing, same idea. The tags, the containers. So this is like the main UI. We have a toolbar, which is I believe is this part, which is actually the search bar. And we have some buttons. We have previous button, the pagination button. We also have the pagination numbers. So you see it's very similar, like a web page design, but it's just using different tags, different names. We also have some specific Android specific things, right? This what is fragment? Fragment is actually this note list, right? The actual record. So it deserves its own, have its own code, and have its own subcomponent, right? It's turtles all the way back, containers within containers. So if you look at that, it's very similar to this is called like a declarative UI, right? You're using something which is like container on top of container to describe your UI component, very much like a web page design. It used to be people written programs for this type of things, right? If you look at this type of things, like HTML or XML, they are not really programs, right? You don't see if else, you don't see a ton of logic. You see those tags or those attributes. So this is more like a database record. If you look at it that way, there's no like if else, there's no loops, right? There's no return, there's no fancy algorithms. But this is very good for UI, because this is kind of directly corresponding to the layout of the UI. So it's kind of why, like, okay, you can have equivalent, right? So this code actually getting generated, like all those code essentially is going to be compiled to some like Java code or JVM code. It's going to be some generated code to actually convert this into something like into some Java program, right? Like in a machine generated code. So it will actually turn those code into like a Java code, and that code actually is like for loops, algorithms, and those components in a like pretty much like those. Right? So you see, similar to JavaScript to HTML, like we have HTML look like this. But if you want like more behaviors, right? Click a button, what we do. We're going to write those handlers. We're going to write those onClick functions. So here we don't have those onClick functions, right? We describe some component. And here we have some code handle those events, right? OnClick functions, which is like, okay, we have those logic here. Right? So you see the different language or different framework, the UI part and the interaction part, they kind of converge to similar patterns, but they just call them different ways. So this is Android, and there is one particular part about how this is using the Rust code. How this is using the Rust core, right? Talking to the database. We said we share the database. We share the same code for database operation. So here's the trick. Here is a JNI libs. You see a bunch of SO files, and I call lib declarative called SO files. SO file is like a it's actually like a C or C++ native code, like a dynamically linked to this Java code. So here we have a Rust bridge, and we define something very specific as system node library declarative core. So here this syntax is a signal to this Java program, this JVM program. We are defining a native library, which is not Java, which is not JVM, but we expose one function, a run function, and this particular syntax, right? We defined a particular run function, and we have a signature for this run function is we input a string, we output a string, and we call this private extend function. That's it. So you can guess, right? This is actually our bridge from the Java code into the Rust code. So let's go back to the Rust side. The actual definition of this sharing is happening is this lib. So lib we defined this piece. We have a PubMod Android and JNI something here. We also define this function unsafe save function Java app declarative Android Rust bridge. This particular function named this particular way, and also we implement it by like some kind of string. We do something, we output a string, right? Something like this. So this is a function which in Rust side we implemented a C function, extend C function, right? So C has a more or less reliable we call it ABI, or like a kind of interface, right? You call a C function, you get something back. So this is in the Rust side we defined a C function which the Java code can call. So which is this one. The naming convention is there's some naming convention, the particular naming convention, but this declarative run function here is exactly this one. So we kind of bridge them together. Any questions? Okay. This is pretty magical, right? Like you kind of cross the language boundaries for different languages and different like so-called cross-platform cross. Um, we'll also look at the other part, the iOS part. iOS part, we have the similar ones, which is defined this way. It's also like some C functions and pretty much the same. If we look at the iOS code, in the X code, we are also doing similar things. This is particular the iOS application. We define something simple. We define a Rust, like a run function here. We have a particular call, right, to this declarative run. We pass in the JSON, which is a string. We get some result back. And so this is like the bridge. There are some other things, right? We define a header, we define something to actually allow the Xcode, allow the Apple iOS device to actually call the Rust function. But similarly, they are kind of leverage the C interface to get this cross language, cross device, cross platform calls. The actual UI for the iOS app is also very similar. You see also a bunch of views. So they have a if you look at the code here, it's similar. We have the search bars. We have this is like corresponding to the search part. We also have the content part. We have a content part. The content part is the record part. There's some behaviors, particular behaviors around different like interactions. Interestingly, here we don't see HTML or XML. I think in the past, so this is Swift UI. Before that, Apple also has something like similar to this kind of tag, container within container. But here you see Swift UI also have this kind of. If you look at this piece, this is also like a container. You see the V stack, like a vertical stack, horizontal stack. This is very much like a layout of the UI. We see the spacer, we see the text, we see the list of nodes. But here is like we don't see those tags, right? The behavior of the UI and the behavior is in a programming language. But the language itself, at least for this UI description part, still look like a container inside a container type of thing. So the good thing is now the UI layout and the logic is unified in one file. Sometimes it's beneficial, right? Like you look at the code, you figure out exactly the search bar behavior is also here in one file. They have the same language. The drawback is also like it can get pretty mixed together, right? The UI code and the logic code is mixed together. So you see those supposed UI code is not clean anymore. We have those behaviors, right? Those functions also in here. What about I click a button, I hide something? You see the actual implementation of the functions also scattered around in this UI layout code. Which way is better? I don't know, but like there are different. This is like a mix together UI event trigger behavior layout, right? Layout mix them together. Sometimes for Swift UI is pretty elegant, right? It's pretty much if you know where to look, the behavior, the actual function code is there. But from here, it's a little bit harder to glimpse the actual layout of the UI, right? Even we have those indentations, but you get those noise of all the actual code here, which is good and bad. So there are a bunch. So we kind of also split the different views into different smaller files. And lastly, I think I want to show the actual compilation process for those two targets, right? So if you look at the Rust, the Rust targets, we have what is target? Target means the targets of the compiled results, the file, right? The actual file. Are you generating a file, executable file, or a library file, or for a particular platform, particular operating system? So on Mac, we have those Apple Darwin by default for this desktop, right? But if you want to compile something iOS can use, is actually not the Mac target, right? iOS is a different system, at least for now. And also they have different architecture. This is like CPU type of things. So when you get to the compiler level, you no longer deal with high-level languages. You are going to deal with something about hardware-specific things, right? So those architecture is basically CPU architecture. We have a different chip for different phones, so the target becomes different now. So the Rust, by default, it doesn't install those target, but we can like using Rust up install those targets to actually have those targets, and then on Android, well, let's talk about iOS first. So on iOS, we have so here, at least for this program, we have something to specifically build the iOS target, like the C shared library for iOS, for Xcode to use. So here is the script for, we use something called air lipo. I don't know what does it mean, but this is the command. You install this cargo lipo like a tool. Then we use this cargo lipo release to compile the local-native core library into a specific crate type called static lib type. So here is some like hacky way of changing the lib type actually in the cargo file. But the end result is, if we do this, it's building something different than the normal target. It's building something at so all the build go into this target folder, but you see the target folder has like different subfolders now, by like architecture, by release, by universal. So this particular command, using this iOS, it's going to build something under universal. So universal means universal iOS device, I believe, or like also like iPad type of things. So you actually create a .a file for iOS. So this .a file is what this Xcode is bridging. So the .a file is actually what this iOS code is going to refer to. For Android side, we see a bunch of so you see it finished. It actually compiled the iOS code. For Android side, we see those Linux, Android, different architecture. We have actually a few. Let's see, we see there's three still. We see these SO files. We see those SO files under Android. Right, this Android SO files. We see these SO files. So this SO file is what actually the what are those? Put it here for the Android to pick it up to actually use in this Rust bridge. So here it is. I think this is a very quick overview of how the mobile device actually calls the same Rust library. Any questions?
Not really. I think I get it.
Cool. So I cannot show the actual, like I was wanting to show like the emulator, but somehow the emulator gave me an error. See, I cannot run. I have some like issue with getting emulator, so I cannot show like emulator running here. For the iOS piece, you can like build for different emulators, like for different emulators. But somehow, because we are using this cross-platform, right? We're using this extend C. We're using this native code. If we build to the emulator, it actually gives me errors. It may be a legit error. It says like this A file, this A is building for it's not linking properly. It's not like the emulator doesn't run properly. But if I'm using actually hook up my device, right? If I'm using this device, it actually can build and can run for majority of it. But the problem is, so when it runs, right? So you see it actually compile runs. You see the log on my phone. This is actually log on my phone. If I'm doing something, so I'm clicking something on my phone, it's actually showing something like the logs, right? And you issue some command. So those are like the SQL statement when I'm clicking on the phone. The problem is when I'm doing like a sync, it crashes. Right? So there are you see some errors, right? Like for when the code actually go into the Rust code, you also see the error actually show like your Rust code has some problem. So this is like a debug cycle when you cross boundary into the native code, but it becomes harder because now you are this Xcode is designed mostly for the like Swift or Object C. Like when you are crossing the boundary, you actually get those dumps. Right? You get into the kind of more raw machine code type of things. Then it's really start getting very specific. How do you approach these bugs? How do you debug the type of things? I think that's pretty much for the things I prepared for today. The last slide I can show the iOS app, like there are certain hooks for getting this like setting up those links to the Rust libraries. So those are things you need to like add to the project. You need to add like a library. This is like a library. You need to find those A files. You need to also add a bunch of other things, like a helper, for it to actually find your external native libraries. Also, there are certain paths. If you search this topic, there are certain paths about like library search paths to actually allow Object-C to allow the Xcode to actually find the A files. For iOS, there is also another thing we use here is called like a pods for reuse, for kind of using third-party libraries, third-party frameworks. We used I think we used one or two of the third-party helper libraries in iOS. So that is defined by using a particular. You can think about the particular iOS manager, right? We talk about the cargo is for Rust, and like npm is for JavaScript, all the other things. For iOS development, there is this pod file, which is not officially like a Apple thing, but like a third party, like a community repository for how do you link other projects. So we use something like this one. We use third party like MM14. So this is a way of, you can think about this as more, it's kind of equivalent to the cargo files dependency specification. So we kind of depend on some third-party library of this version, and we define some way of using it, like, so you see those versions for different target, whatever, and this pod command is like the cargo command, if you think. Is kind of to manage the dependencies. So it's written in Ruby for managing those for managing the dependencies. So there are like I think pod install or like a pod update, those commands to install those third-party libraries, and once they are hooked up in the code, we can use it. So you see they're very similar, right? For different languages, different frameworks, they heavily rely on the ecosystem, the libraries, the package managers, the versions. But in the end, they all look very similar. Right? You have a pod file, you have a cargo file, you have some package file, things like that. Okay, I think that's pretty much it is. We'll wrap up here and see you next time.
Thank you. Bye-bye.
Bye.